Okay, so what we're going to talk about today is an application of derivatives called elasticity of demand. It's the only application that we're going to do out of chapter 14. Well, not the only one, but the major topic. We're going to do 14.3. So first we need to talk about what is elasticity of demand. What are they talking about? And there are notes if you need them in Shobi. But basically, if you sell something, a product or a service, either one, the main thing you're going to be concerned about is how a change in the price is going to affect the demand for your product. And the sensitivity of demand to changes in price varies with different items. Luxury items tend to be more sensitive to price than essentials are. And for things like milk, heating oil, or heating fuel, light bulbs, a relatively small percentage change in the price isn't going to change the demand very much, because those are things, regardless of how much they cost, we kind of need to have them. And luxury items, for example, jewelry, concert tickets, and sometimes cars and homes, a small percentage change in the price can have a lot of effect on the demand. So we're going to talk about some examples of when demand is elastic and when it's not. One of the ways to measure the sensitivity of demand to changes is by the relative change, or the rate of change, which is the ratio of the percentage change in demand to the percentage change in price. So, as usual in our demand functions, Q represents the quantity and P usually represents the price. So the ratio is going to be the difference in quantity divided by the quantity, and the difference in price divided by the price. That's how you're going to get your percentages. And delta Q, which that little triangle is red delta, represents the change in Q. So the change in Q divided by Q represents the change in Q, and change in P turned into percentages. Basically what that means is, because Q and P are always positive, delta Q and delta P are going to have opposite signs. Either the price is going to go up, which will drive down demand, or demand is going to go up, which may lower the price. So an increase in price basically can cause a decrease in demand. And if the absolute value of that ratio is large, it's going to tell us that a relatively small increase in price is going to cause a relatively large drop or decrease in demand. Yeah. Now, I'm not going to go through all the calculus of it, but if we take the limit of this, and if you're wondering how these got separated, remember what we had was delta Q over Q divided by delta P over P. And since you're dividing, that becomes delta Q over Q times P over delta P. And you wind up with this because you're just simply rearranging your terms here. P over Q, delta Q, delta P. Now, if you take the limit of this quantity right here, as the price approaches zero, which of course you know your price is never going to get to zero, and it's never going to be zero or be negative, but it can get lower and lower. So basically we're not saying that it's going to be zero, but what happens as the price drops? What happens is it gets lower and lower. The negative of this quantity is called the elasticity of the demand, which is E. And it measures the instantaneous response of demand to price. So in order to calculate E, the elasticity of demand, you simply take the negative of the price over the quantity times the derivative of quantity with respect to price. Because when you take the limit, what you're doing is you're taking the derivative. Demand is inelastic if E is negative, if E is less, or excuse me, not if it's negative, if E is less than 1. So it's inelastic if E is between 0 and 1. It is elastic if E is greater than 1. And it has unit elasticity, which we'll talk about what all of these mean, if E is equal to 1. Let's talk about what each one of those terms actually means. And we'll keep this handy. So here's a couple of examples. E is estimated to be 0.6, which means it's inelastic for physician services, and 2.3 for restaurant meals. You have to go to the doctor. So your elasticity of demand for physician services is inelastic. Okay? Because you have to go to the doctor. Changing the price doesn't change your need to go to the doctor. Now, elasticity is greater than 1, and therefore demand for restaurant meals is elastic. Meaning you don't have to have that restaurant meal. You could go home and eat. Okay? You could pick up something cheaper than eating in a sit-down restaurant. So that's something you might forego. So elastic demand means people might not buy it. If the price goes up, they'll say, well, I'm not doing that. Whereas inelastic means the price is going to change, but they don't have much choice. They have to have it. So basically what's happening here is that the demand for non-essential commodities, such as the restaurant meals, is going to be inelastic. I'm sorry, elastic, not inelastic. So inelastic means a small change in price has very little effect on demand, but elastic means a small change on price has more effect on demand. And in fact, the larger the value of E, the more effect it's going to have. When E is equal to 1, the changes in price and demand are relatively equal, and that's why we say that it has unit elasticity. Now the calculation is not difficult with these. And here's an example of a commodity. Terence Wells described the demand for distilled spirits as Q is a function of price, and Q and P are related by negative 0.00375 times the price plus 7.87. And of course this the price is in dollars and Q is the quantity. It doesn't give us units for, well, yes, actually it does. It says P represents the retail price, which is dollars of liquor, and it's in dollars per case. Okay, so Q is a function of the price in dollars per case of liquor. And Q represents the average number of cases of liquor purchased per year by a customer. And they want us to calculate the elasticity of demand when the price is $118.30 per case. Now, looking at the demand for distilled spirits and thinking about what we're talking about here, would you expect the demand to be elastic or inelastic? You would expect it to be elastic. If I don't need it, price goes up, I'm not gonna buy it, okay? So what we're gonna do then to actually solve this problem is we are going to take the derivative of Q. Skip through my notes, make sure I'm getting the right answers on everything. So what's the derivative of Q? Should be pretty easy. Mm-hmm. So we've got the derivative. Now we need to calculate elasticity because the derivative is part of elasticity. Because this is the differential notation for this, okay? So elasticity the derivative is negative 0.00375, and P is $118.30 a case. So this is going to be negative P over, now remember this negative is because they have opposite signs. This is the formula for Q. And the price is just simply the price. Okay? So E turns out to be this. Actually, that's going to be positive because this is negative and this is negative, so that makes that positive. Okay? Over negative 0.00375 times P plus 7.87. And there's no units here because they've canceled out. E is it's like a coefficient. So now all we need to do is we need to plug in $118.30.
So the top is positive and the bottom stays negative?
Yes. And the reason for that is that the whole quantity, let me put the formula back up here for E again. This turned out to be a negative quantity. Okay? So that's negative. And because this whole thing is negative, then the negative cancels out and the whole numerator becomes positive. But the function in the bottom has a negative leading coefficient, okay? So what we're gonna do is we're gonna plug in a price of 118.30. So we'll get a calculator, do some arithmetic. And I should not have made that negative, so let's delete that negative sign. So your numerator is 0.443625. And then in the denominator, we have the same quantity, but it's negative. Well, just go ahead and write that down. Plus 787. So we're going to divide that by negative 0.443625 plus $7.87. And E turns out to be 0.059. Okay? Now, since E is between 0 and 1, what does that tell us about the elasticity? It's inelastic. Now, inelastic means that people are basically going to buy it regardless of what they're charging for it, okay? At that price. At that price. Now, if the price was much higher, that might not be the case, okay? At a different price, that might not be the case because you determine elasticity for given prices. Now, if you're thinking about a case of liquor, a case is, how many bottles? 12. And at $118 a case, $118.30, that's less than $10 a bottle. Are people going to buy it at that price? Yeah. But if you doubled or tripled the price, they might still, depending on what the spirit was. So that's a relatively low cost, and that's why you need to take into account that the elasticity is at a specific price. Here's a similar one. This one is about beer. Demand for beer was modeled with the function, back that out a little bit, Q equals F of P equals 1 over P. The price is expressed in dollars per can of beer, and the quantity sold is cans per day per adult. So what is the elasticity of demand? Okay, remember your formula. Elasticity is the opposite of price over quantity times the derivative of f of p. So price over quantity, which we don't have a price yet, but we can find this derivative. So what's the derivative of 1 over x, or 1 over p? So it'd be negative 1 over p squared, right? You can, but think about what we've got to do with it. Okay? So sometimes it's worth it to actually simplify something. I don't usually make you, but in this case it's worth it, because in order to get a formula for elasticity of the beer, to use it, we need to actually multiply this out, and it will be easier to multiply times negative 1 over p squared, since we have two fractions. Okay, negative times negative is positive. P times 1 is p over q times p squared. And in this case, this p will cancel out one of those, so it actually turns out to be 1 over q times p. Everybody good there? Because we need to make one more change. I haven't done the final step yet. Now, since we actually need the ratio, what is Q equal to? One over P. I think if there's not a simpler way to simplify that. Yeah, let me skip back a couple of steps. I think it'll make more sense to you if I substitute in a little bit earlier. It'll be easier to follow the arithmetic. Equals negative P times the derivative, which is negative 1 over P squared. And let's just go ahead at this point and substitute in Q is equal to 1 over P.
Where do you get that from? Oh, you just take it from the...
Yeah, you take it from the original formula, okay? So if we do that, then this whole quantity here, I'm not going to fool with this for a minute. I'm going to leave that sit. This whole first quantity is negative P times P over 1. Does everybody understand this part? Because all you're doing is dividing by 1 over P, and we've used that trick before where you're dividing by a fraction, flip the fraction over, and then multiply by it. So then I have negative P times P is negative P squared over 1. And now I'll bring down my negative 1 over P squared. So there's your elasticity. So what is negative P squared over 1 times negative 1 over P squared? 1. Because your P squareds cancel. It would be positive 1 because negative times negative, remember, is positive. So it's going to be positive 1. What does E equals 1 mean about the elasticity? It has unit elasticity. Okay? It has unit elasticity. And that means the percentage changes in both those quantities are basically equal to each other. They're going to kind of wipe each other out. And that means basically, since you want to know ultimately what this means is that revenue is going to remain pretty consistent because the demand doesn't change much based on price. They stay relatively in harmony. So what that means long term your revenue is going to be relatively stable. It's not going to change a whole lot. So that's actually the next topic that we're going to take up. Just a quick summary here. If the demand is inelastic, total revenue increases as price increases. If the demand is elastic, total revenue decreases as the price increases. If you have a unit elasticity, your revenue is maximized. That's an important thing to know about. Unit elasticity maximizes your revenue. Okay? And if you are the business person, you want demand to be inelastic, hopefully. But that tends more to happen when whatever it is that you're selling or producing is something that is a necessity. But you want inelastic demand because your revenue will increase as the price increases. Now I've got a graph, and this might be, if you're actually trying to take notes for the next test or trying to make note of something you want to pay attention to, picture this graph. This is your revenue. This is your price. As your price increases, at first, your revenue is going to be, your demand is going to be inelastic, which means your revenue is going to go up. But once it hits a maximum point, your revenue is actually going to decrease because it becomes more elastic. This is where you want to be. Now, for those of you that have had province stats, this probably would remind you of a bell curve, and it actually is. This is it's like the normal distribution for province stats. So let's look at example 5. Example 5 says, assume that the demand for a product is Q equals 216 minus 2p squared, and p is the price in dollars. Find the price intervals where the demand is elastic and where is it inelastic, and then what price is going to result in the thing we're most interested in, maximum revenue. And then what is the maximum revenue? So here we've got that Q is 16 minus 2p squared, and we need to calculate elasticity, which is negative P over Q. And no, I don't expect you to memorize that formula. I'll give you the formula. Times the derivative of Q with respect to P. So we've got P over, this is the value of Q, and this ratio is always negative, times the derivative of 216 is 0, minus 2 times 2 is 4, and that's times P to the 2 minus 1, so that's just 4P. And this is also negative, remember, because 2 times negative 2. So in the end, we have negative times negative is positive. And P times 4P is 4P squared over 216 minus 2P squared and if I was my math lab, I would say, oh, you really want to simplify that. Well, I don't care if you do or not. What we want to do is we want to find out where it has zeros. Now, you can simplify it to help you find the zeros, or you can graph it to find out where it's zero. Right? So let's just graph it and see if we can figure out where it has zeros. Where is it positive? Where is it negative? And we can do that actually lots of different ways. We could even look at a table of values. So I'm going to go here to my calculator, and my numerator is 4x squared divided by the quantity 216 minus 2x squared. And we'll set up our table to auto. So we'll start with one unit and see what happens. So let's go look first at the table, and we see what happens pretty quickly. It's inelastic until you get to 6. When your quantity is 6, you've maximized your revenue.
So you set that to auto?
Yeah, I just set it to auto. I mean, you could actually leave it on ask and just type in 1, 2, 3, 4, 5, 6, 7. But I set it to auto so that we could scroll if we needed to. So what we see is that E is less than 1. Or not when the quantity, when the price is from $1 to $5. E is equal to 1 when the price is $6. And E is greater than 1 when the price goes above $6. Okay? So that answers the question, what price results in maximum revenue? So $6 per unit maximizes the revenue. Now the question is, what is our maximum revenue? How are we going to figure that out? Say again, Kate? Well, think about, all that's going to give us is a quantity, okay? But how do you find revenue from quantity? Multiply it by the price. Revenue is quantity times price. So the revenue for 6 is going to be 216 minus 2 times 6 squared times 6. So we have 216 minus 6 squared is 36, and 2 times 36 is 72 times 6. So our maximum revenue is $864. Any questions?
You scoot over, Sylvia.
Yes.
Why did we multiply at the end of our estimate? Why did we multiply again by 6?
Because this is your quantity, and this is your price. Okay? Because you're multiplying quantity times price, and quantity is given by the original equation. Okay? Anytime you're trying to find revenue, it's always quantity times price. Questions? That's really all there is to this section. That's it. So it's just more practice at taking derivatives and then applying it to a formula to help you determine elasticity of demand. So our last topic, and this one actually depends upon how algebraically